Okay, so we found the relative max is negative 5, 249. The relative min is 5, negative 251. And now we're going to have to test, we're going to have to find different intervals. Um, so the intervals only exist to the left and right of the critical values, and the critical values are negative 5 and 5 and 5. So we're going to test f prime at greater than 5, and then we'll test at a number between negative 5 and 5, and then test another number to the left of negative 5. So I will set f prime to 6, set f prime to 0, and then set f prime to negative 6. If I set it to 6, it is going to give me a positive 33. If I set f prime to 0, it's going to give me a negative 75. And if I set f prime to negative 6, it's going to give me 33. So because there is a... okay, so after 6, there is an increase. Oh, it's a positive number. So it goes from positive to negative to positive. This is going to show, the 6 is going to show an increase from negative infinity on the graph to up to negative 5. So increase from negative infinity to negative 5, and also from 5 to infinity when we test these values. And it's going to be decreasing from points negative 4, negative 4, 4. Okay. Okay, now we have to find the points of inflection. Okay, so set that there. Okay, so to find the points of inflection, there is a point of inflection at x equals 0. So we set f double prime to 0, which would give us 6x equals 0. Okay, hold on. Okay, got it. So inflection happens at x equals 0. So we have to test an f double prime test at before and after 0. So we will set at f double prime, we will set x to negative 1, and then we will test it at 1. So 6 times negative 1 equals negative 6. And we're just testing for a change in sign to show a point of inflection. And then we'll test 6 at 1 on the other side of 0, and that is 6. So the change of sign indicates that there is a point of inflection at x equals 0. Okay. And to test that, okay, so to find the point of inflection, we are going to set the original function, f of 0 equals 0 to the third minus 75 times 0 minus 1 is going to give you equals -1. And that is going to be your y value. So you know that your point of inflection is at 0 and -1. So if okay, so that's pretty much what we're gonna need for what we're gonna need to graph. Last thing to do is to graph. We have our relative max, relative min. We have a point of inflection at 0 and -1. And we need to test concavity. Okay, so if we put, so we know that at the negative value, so if at -1, at -1, the f double prime is -6. So that means that if f double prime is negative, then there's going to be a concave down, and that is going to be from points -infinity to 0. And then on the other side, when f double prime is positive, you're going to have a concave up. And that is going to be from the other side, 0 to infinity. So that is concave down, and this is going to concave up. So we have our relative max, relative min, point of inflection, and concavity. So if we draw this, we're going to see the pretty small x values, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're going to have to go higher on the y values, probably intervals of 50. So 50, 100, 150, 200, 250, 300, 50, 100, 150, 200, 250, 300, and then we'll go 350. Okay, so our point of inflection is going to be 0, -1. That's probably a little off. The relative max is going to be -1, 2, 3, 1, 2, 3, 4, 5, and positive 249, 51, 152, 250. Okay, so that's relative max. Relative min is going to be x's 1, 2, 3, 4, 5, and -251, 51, 152, 250. So we're about right here. The concavity, concave down is from -infinity to 0. So we're going to have this look. And then concave up from 0 to x is 0 to infinity. So it's going to concave. Ooh, I didn't put the relative. This should be like right over here. I just drew it off. So that's the shape of the graph. Those are the coordinates. That should be pretty much everything. Hopefully I did it right. Thank you.